Hello children, I am back with the second video on the chapter spectrum, and in this we are going to discuss electromagnetic spectrum and its broad classification. So let's start with. Till now we have limited ourselves to the spectrum of light which lies between the red and the violet regions. This spectrum is the visible spectrum, and it is only a very small part of the entire electromagnetic spectrum. Experiments show that the spectrum of sunlight is limited not only between the violet and the red extremes, but it extends on either side beyond these extremes to which our eyes do not respond. The part of spectrum beyond the red extreme and the violet extreme is called the invisible spectrum. The waves of wavelength longer than the red part of the visible spectrum in increasing order of wavelength are infrared radiations, microwaves, radio waves, while the waves of a wavelength shorter than the violet part of the visible spectrum in decreasing order of wavelength are ultraviolet rays, X rays, and gamma rays. These radiations together form the electromagnetic spectrum. These electromagnetic waves are of different wavelengths, but they have properties similar to the light waves. The speed, frequency, and wavelength of electromagnetic waves are related as speed is equal to frequency into wavelength. Now let's talk about the properties common to all the electromagnetic waves. The very first property is all the electromagnetic waves do not require any material medium for their propagation. Second, they all travel with the same speed in a medium. For example, in vacuum, the speed is 3 into 10 raised to power 8 meter per second. In glass, the speed is 2 into 10 raised to power 8 meter per second, and so on. Third, they exhibit the properties of reflection and refraction. In refraction, when an electromagnetic wave passes from one medium to another, there is change in its direction of travel, speed, and wavelength, but the frequency remains unchanged since the source is same. Fourth, these waves are not deflected by any electric or magnetic fields. Fifth, these waves are transverse in nature. Now, we are not going to discuss all the parts of the electromagnetic spectrum, but we are supposed to discuss only ultraviolet radiations and infrared radiations. So, let's start. The electromagnetic radiations of the wavelength from 100 angstrom to 4000 angstrom are called the ultraviolet radiations. The ultraviolet part of the spectrum was first detected by Professor J. Ritter in 1801. So, how to detect these radiations? If silver chloride solution is exposed to the electromagnetic waves starting from the red to the violet end and then beyond it, it is observed that from the red to the violet end, the solution remains almost unaffected. But just beyond the violet end, the solution first turns violet and then finally it becomes dark brown. It shows that there exist certain radiations beyond the violet extreme of the visible part, which are chemically more active than the visible light. And these radiations are called ultraviolet radiations or actinic rays. The ultraviolet radiations can be detected by their chemical activity on dyes and photographic plates. The spectrum of ultraviolet radiation is obtained when they are passed through a quartz prism in place of a glass prism, because glass absorbs these radiations. Now let's find out the sources of ultraviolet radiations. The electric arc and sparks give ultraviolet radiations. A mercury vapor lamp emits radiations, a part of which has ultraviolet radiations along with the visible light. Sun is also a source of ultraviolet radiations, but a large fraction of it is absorbed by the ozone layer present in the Earth's upper atmosphere, which protects us from its harmful effect. Now let's discuss the properties of ultraviolet radiations. Ultraviolet radiations can pass through quartz, but they are absorbed by glass. Therefore, to obtain the ultraviolet spectrum from its source, a quartz prism is used instead of a glass prism. For the same reason, the ultraviolet bulbs have the envelope made of quartz instead of glass. Ultraviolet radiations travel in a straight line with a speed of 3 into 10 raised to power 8 meter per second in air or vacuum. They are usually scattered by the dust particles present in the Earth's atmosphere. They obey the laws of reflection and refraction. They strongly affect the photographic plate as they are chemically more active than the visible light. They produce fluorescence on striking a zinc sulfide screen. Harmful effect of ultraviolet radiations. The ultraviolet radiations cause health hazards like skin cancer if human body is exposed to them for a long period. Uses of ultraviolet radiations. Ultraviolet radiations are used for the following purposes: for sterilizing purposes, for detecting the purity of gems, eggs, ghee, etc., in producing vitamin D in food of plants and animals. The second part of the spectrum that we are going to discuss is infrared radiations. These radiations are of the wavelength in the range of 8000 angstrom to 10 raised to power 7 angstrom. The infrared part of the spectrum was first detected by William Herschel in about 1800. If a thermometer having its bulb blackened is moved from the violet end towards the red end, it moves from the violet end towards the red end of the spectrum of visible light. It is observed that there is a very slow rise in temperature. But when this thermometer is moved beyond the red extreme, a rapid rise in temperature is noticed. It means that the part of the spectrum beyond the red extreme of the visible light has certain radiations which produce a strong heating effect, but they are not visible. These radiations are called infrared radiations. A thermopile can also be used to detect the heat radiations. The galvanometer connected with the thermopile shows deflection when infrared radiations fall on the thermopile. The spectrum of the infrared radiations is obtained by using a rock salt prism because the rock salt prism does not absorb the infrared radiations, whereas a glass prism absorbs them. Sources of infrared radiations. All red hot bodies, such as a heated iron ball, flame, fire, etc., are the sources of infrared radiations. The sun is the natural source of infrared radiations. Properties of infrared radiations. Infrared radiations travel in straight line like light with a speed of 3 into 10 raised to power 8 meter per second in vacuum or air. They obey the laws of reflection and refraction. If a source of heat, say infrared lamp, is placed at the focus of a parabolic mirror, a parallel infrared beam is obtained. A burning glass focuses the more energetic infrared radiations obtained from the sun on a paper, due to which the paper churs. They do not affect the ordinary photographic film. However, a specially treated photographic film is affected by them. They are absorbed by glass, but they pass through the rock salt. They are detected by their heating properties using a blackened bulb thermometer or a thermopile. They are scattered less by the Earth's atmosphere because of their long wavelength. Hence, they can penetrate deep inside the atmosphere, even in fog. The greenhouse gases, such as carbon dioxide, present in the Earth's atmosphere, absorb the low energy infrared radiations and keep the Earth's surface warm. Harmful effect of infrared radiations. A high dose of infrared radiations may cause skin burns. Uses of infrared radiations. The infrared radiations are used for therapeutic purposes by doctors. They are used in photography at night and also in mist and fog because they are not much scattered, so they can penetrate appreciably through it. Infrared lamps are used in dark rooms for developing photographs as they provide some visibility without affecting the photographic film. They are used as signals during the war, as they are not visible and they are not absorbed much in the medium. They are used in remote control of television and other gadgets. With this, we finishes with the chapter Spectrum. Thank you for watching the video. I hope you must have learned new facts and concepts related to electromagnetic spectrum. Goodbye. God bless all of you and take care.